There's a calendar in your pocket. It tells you the day, the week, the season, when to plant, when to harvest, when the sun will rise, and it works. Every single time. You probably think of that as a modern miracle, a gift from satellites and supercomputers. But here's the thing, that calendar is a promise. A promise first made by people who had no telescopes, no paper, no written math, and no idea that the Earth moves at all. They made the promise anyway, and they've been keeping it ever since. So the question is simple. How did ancient humans predict the sky long before we understood it? To answer that, we need to go back to a time before writing, before cities, before farming, before anything we'd recognize as a civilization. And we need to look up, because the sky was the first machine humanity ever had, not built by anyone, but it ran on a schedule you could set your life by. The sun rose and set, reliably marking days. The stars turned overhead in the same pattern every single night. The moon grew full, shrank to nothing, and came back over and over on the same rhythm, and there was more. 5 bright lights moved among the fixed stars, not wandering randomly, but following their own paths night after night. We call them planets from a Greek word that means wanderer. Mercury, Venus, Mars, Jupiter, Saturn, to ancient eyes, they were wanderers in a sky that otherwise never moved. And here's the realization that changed everything. If the sky keeps a schedule, if the moon is full on a regular rhythm, if the seasons turn on cue, then you can plan around it. You can know when to move, when to gather, when the rains will come. And the only way to hold onto that knowledge in a world without writing is to remember it, to record it, to keep the sky's schedule in your hands. Which brings us to the first record. A bone carved about 20,000 years ago in what is now the Congo. It's called the Ishango bone, and on its surface are notches. Not random scratches, clusters, groups of 11, 13, 17, 19, numbers that mean nothing at first, but match them against the phases of the moon and they line up. The lunar cycle, days between full moons, new moons, the intervals that separate one phase from the next. Whoever carved that bone was not doodling. They were keeping a ledger. The first record humanity ever kept, the first thing we ever wrote down was the moon. A bone became a database. And that database told you what the sky was going to do next. But a notched bone has limits. It can hold one pattern in one hand for one person. A civilization needs something bigger, something the whole community can read together. So the record grew up from a tally stick to a place. About 7,000 years ago, in the Egyptian desert, someone arranged a ring of standing stones. Nabta Playa, a circle of stones placed with such care that it lines up with the solstice, the exact point where the sun stops its drift and turns back. It's considered one of the oldest calendar circles in the world. And across the continent, in what is now Germany, another ring went up around the same time. Goseck Circle, nearly 5,000 years before the Common Era, a circle of ditches and timber gates, with gateways so precisely placed that the sun, on the solstice, rises and sets exactly through them. People stopped counting the moon on a bone. They started building its schedule into the land itself. Stone, aligned to the sky. The database moved from your hand to the horizon. Then, around 1600 years before the Common Era, someone did something stranger. They made a map. The Nebra sky disk. A disk of bronze, about 30 centimeters across, found in Germany. On it, in gold, a sun or a full moon. A crescent moon, 32 stars, and among them a cluster of 7, the Pleiades. The oldest concrete depiction of the sky ever found. But here's the part that matters. It was not art. It was a tool. 2 gold arcs on its edges, their ends span about 82 degrees, which is exactly the angle between the sun's rising point at the summer solstice and its setting point at the winter solstice, at that latitude. The disk told its owner when the year had drifted. If the crescent moon appeared beside the Pleiades at the wrong moment, it was time to insert a leap month, to drag the calendar back into line with the seasons. Bronze Age farmers, who could not read or write, were running a calendar so precise it needed a leap month rule. And the disk's gold and copper were traced to sources in Austria and England. The knowledge and the metal traveled. The database had gone international, so by the Bronze Age, humans could predict the seasons. The moon, the sun, the regular machinery of the sky, but the sky has more than a schedule. It has moods, and those moods terrified people, because not everything in the sky keeps time. A comet appears out of nowhere, burns across the sky, and vanishes. An eclipse turns the day to night in the middle of the afternoon. And sometimes, rarely but terribly, a new star appears. In a sky that is otherwise fixed forever, a light shows up where no light was. And ancient people, watching that, ask the only question a database can't answer. What does it mean? That question built an entire civilization. In Mesopotamia, about 3,000 years ago, the Babylonians decided that the sky wasn't just a clock. It was a message. Every event up there, every eclipse, every planet, every wandering light was a sign addressed to the people below. And the messages were not good news. A lunar eclipse in particular meant one thing, the death of the king. So imagine being a Babylonian priest. You believe the sky sends warnings. You believe an eclipse foretells the king's death. And you serve a king who really does not want to die. What do? You write everything down, every night. For centuries. That's exactly what they did. Babylonian astronomers kept what we now call astronomical diaries, night-by-night records of planets, eclipses, the weather, even the price of grain. They compiled thousands of omens, each one tying a specific event in the sky to a specific event on Earth. The Enuma, Anu, and Lil, a library of signs, and none of it was science as we'd recognize it. It was superstition, with receipts. But here's the twist. Those receipts, that mountain of accumulated data, began to reveal a pattern. Somewhere around the 7th or 8th century before the Common Era, the Babylonians noticed that eclipses did not strike randomly. They returned, over and over, in the same order on the same interval. 223 lunar months, about 18 years, 11 days, and 8 hours. We call it the Saros cycle. The Babylonians called it something simpler, the reason they could predict the future. Because once you have the pattern, you can forecast the exception. They predicted when the sky would break the rules, and some of their tablets do it accurately, to within minutes. That's the moment astrology became astronomy. That's the moment fortune-telling became math. The Babylonians thought they were reading messages from the gods. They were actually building the first scientific database in human history. And it worked. So well that they could neutralize a prophecy. Because if you know an eclipse is coming, you can perform the rituals in advance and spare the king. The database outlived them. It outlived everyone. Across the world, in China, astronomers kept an even longer watch. From around 750 years before the Common Era, they logged eclipses, more than 1,600 of them, written down, preserved, numbered. And they watched for something else, guest stars, new lights appearing among the fixed stars. In the year 1054 of the Common Era, a guest star appeared in the constellation Taurus. It was bright enough to see in daylight. It stayed for months. Chinese and Japanese records describe it precisely. And modern astronomers, reading those ancient diaries, match that record to a swirling cloud of gas we now call the Crab Nebula, the remains of a star that exploded. The supernova of 1054. An omen once. Now, a data point in the story of the universe. The diaries that began as superstition became the record that let us understand the death of stars. So, every time you check the date, every time you glance at a weather forecast, every time you trust that the sun will rise tomorrow, you are reading the same database. The notches on a bone in the Congo, the ring of stones at Nabta Playa, the bronze of the Nebra disk, the clay tablets of Babylon, the eclipse records of China, one continuous project. Humans refusing to let the sky be random. Think about that for a second. The ancient world did not invent science because it was smarter than us. It invented science because it was afraid. The sky was terrifying. Eclipses killed kings in their imagination. Comets were omens. New stars were messages. And fear has a beautiful side effect. Afraid people write things down. They keep records. They look for patterns. They build databases because a database is a way to make the scary thing predictable. To take the terror out of the sky and put it in your hands where you can read it. And that is what they did. For all that time, we watched the same sky they watched. The same moon. The same 5 lights that wouldn't sit still. The same sun. We didn't invent the calendar. We inherited it. We just got the receipts. Remember the number, 223 lunar months. 18 years, 11 days, 8 hours. That's how long the sky's secret pattern takes to repeat. An ancient priest figured that out by carving the night after night, into clay, believing he was reading the will of the gods. He was actually building the machine your pocket calendar runs on. And all these millennia later, you carry it with you. Every day, without thinking. That's not a modern miracle. It's an ancient one kept faithfully by everyone who ever looked up and refused to let the sky win. So the next time you check the date, take a second. Somewhere in that tiny grid of numbers is a promise, made by a people who had no telescopes, no writing, and no idea the Earth moves. A promise that the sky can be understood, that the chaos can be mapped, that the scary things above us can be predicted and tamed and written down. They kept it. Now you get to hold it. Look up tonight. Same sky, same moon, same machine, still running, still keeping time, still waiting to be read.